Welcome to the video for the demo Interactive Multimodal Photobook Co-Creation in Virtual Reality. Interactive deep learning, especially human-in-the-loop systems, have shown to enable adaptability and robustness of deep learning systems. They consist of three parts: the user, an interface, and a deep learning model, which usually is trained before its first iteration in the loop. The deep learning model is used to compute predictions, with which the user can then interact with. In co-creation, humans provide guidance while AI generates diverse content and supports iterative development, unlocking new solutions across different domains. While a lot of research goes into how to make deep learning models and their training better, most systems restrict the user to mouse and keyboard as input modalities, missing the opportunities of a multimodal interaction in an immersive environment. In our approach, we replaced the monitor with a virtual reality or VR headset. This allows us to go from 2 to 3 dimensions. Additionally, it enables us to use multiple modalities such as speech, controllers, and gaze, which might be considered more natural to the user. The VR setup could also allow more modalities such as face recognition, poses, and many more. Multimodal interaction provides added flexibility, increases user satisfaction, and enhances task efficiency when interacting with a model. In VR, combining gaze and speech inputs can simplify virtual interfaces by creating shortcuts, thereby reducing interface complexity and improving overall usability. For an instance, speech-based interfaces lower the barriers to expressing intent and enable flexible natural language interactions, while eye tracking offers hands-free interactions by allowing users to engage with elements simply through gaze. The combination of immersiveness and advanced interaction techniques in VR presents unique opportunities for enhancing interactive deep learning, or IDL, and human-AI co-creation systems. In our demo, we present this setup in the use case of photobook generation. Photobooks are an ideal testbed because they entail multiple different deep learning tasks, namely image retrieval, instance detection, and caption generation. The architecture of our demo follows the display and data processing layer separation, also called front and backend. First, we have the user with different interaction modalities. They interact with our front end, which is built using Unity and the OpenXR toolkit. Our display is in Vive XR Elite. The front end then communicates with the backend via a RESTful API. The backend entails multiple tasks, most importantly, the machine learning services, object detection, caption generation, and image retrieval. Let's now have a look at the demo. We start in an overview scene of our photobooks. Currently, we only have one photobook created and could create a new one. Instead, let's open the photobook about Alice's and Bob's trip to New Orleans. We can see that the photobook already contains one chapter titled Mardi Gras World, but we want to add a chapter about our visit to the Audubon Aquarium. We can do so by clicking or looking at the Add New card on the right, but we can also add it by giving a spoken command. So we say, create a new chapter about Alice's and Bob's trip to the Audubon Aquarium. Include images of us, the turtle, and the colorful fish. The backend creates a chapter with images and captions based on our query. Inside, we can see that there are 4 images and, as requested, 2 images of Alice and Bob, 1 image of a sea turtle, and 1 of fish. Let's have a closer look at the image of the turtle and choose a different caption for this image. By looking at the caption for longer, we open up a radial menu showing us alternative captions given by the backend. Again, through gaze dwelling, we can select a different caption. We can also change the image itself in the same manner. When dwelling on the image, or clicking it, the backend searches for similar images in the photobook images data. We are again presented a radial menu with different options and choose another image by dwelling on it or clicking it with the controller. The original image will be replaced, and we can move on. Looking at this image of Alice in front of the jellyfish tank, we can see that the backend misidentified her as Bob. If we dwell on the image, we can see the bounding box with the label Bob confirming this suspicion. To correct this mistake, we can look at the bounding box or the caption and say, "This is Alice, not Bob. Please correct this mistake." The backend will incorporate our feedback and relabel the bounding box. Additionally, it regenerates the caption with the new context. We can see that it replaced Bob with Alice in the caption. Our tool allows for natural interactions and adequate feedback, potentially improving human-in-the-loop systems. Thanks for watching.